Hi. Thank you for coming. My name is Julie Matviyuk. I work for Symantec. I have been working for Symantec for 13 years, and I work in security response, which is the department that produces the detection for the security software. So they produce either like little fingerprints for files or traffic or websites, or decision trees they produce, or any means that the software, the antivirus software, will be allowed to detect malicious behavior. And I started off in QA as a QA engineer, and my job is not to produce those detections. My job is to try and make sure they don't make mistakes and detect the wrong things and block the wrong things. And the reason I'm here is a few years ago, I was watching Roland Garros with a friend of mine, and the player messed her serve twice, and the serve passed to the other player. And he said to me, they have full control over the serve, and that's all they train for all day long, every day. So why do they still mess the serve? And it was obvious to me that it's a trade-off between power and accuracy. And when you reach 100% accuracy at a certain level of power, you just put more power in. But it wasn't obvious to him at all. And it got me thinking, is that what you think of us, you as software developers? We are training security software all the time. We have the most advanced algorithms. We have deep learning algorithms. We have the smartest people working on those detections. And yet, sometimes, we still get it wrong. And I was wondering, maybe would you like to know why? What it is that trips us up. So the first thing I'd like you to understand is that the decisions are not deterministic. So a security software is going to weigh the pros and cons about attributes of what it's looking at. So if it's looking at traffic, or it's looking at a website, or it's looking at software or at a file, it's going to look at attributes. Where it comes from, have I seen it before, what does it do, is it something I know is malicious, is it trying to hide itself, what is it doing? And then it's going to balance all those attributes using machine learning algorithms, or using decision trees, or using any static detections. And it's going to decide to create a report or not, an alert. Sometimes your software is going to fall in the middle, or your website is going to fall in the middle. And sometimes it's going to fall in the corner. That's when there's not enough information available to that part of the security stack. And a lot of the time, this is avoidable. Like, there are simple things, 10 simple things we could do to make both softwares work safer and better, both the softwares you're producing and the security software. Also, those lines which decide which decision is going to take, they're not deterministic either. They're depending on the setup and the configuration. You're not going to secure a bank infrastructure the same way you secure your home computer or your grandmother's computer when they are browsing the internet. So this can be set with configuration. So it's not always possible for you to know ahead of time, is this file going to be detected? Or is my website or is my traffic going to trigger an alert by the security software? But there are things you can do to ensure it edges on the green side. The security software has layers. Sometimes you call it a security stack. And on the outer layer, you have the cheapest protection, which is the security policy. And then you have the network protections, all the way down to the core, which runs on the endpoint. And then you have the endpoint security, and then you have the backup. And when everything goes wrong and you get infected, you can always restore from backup. All those layers work differently, and they're going to take the decision based on different attributes. And not the same attributes aren't available to each layer of the stack. And even sometimes different layers of the stack can be provided by different vendors. You don't have to have an entire stack from one vendor. So they don't necessarily communicate the way you think they should. So on the outer layers, when you're looking at traffic and you're looking at files being downloaded, you might have a lot more context. Like, you will know where it comes from, where the traffic comes from. You will know who else has downloaded the file before. But you will have a lot less time and a lot less resources. You'll have to take a snap decision based on restricted attributes. Whereas towards the core, on the endpoint, you will have the leisure of trying to decrypt something, decrypt a file. You can try to emulate a file and see what it does. You can just observe the behavior of a software and decide based on what it does whether you want to alert and block it or not. But you might have lost some of the context. For example, if you are in a bank infrastructure and you want to install Microsoft software, most likely you're not going to go to Microsoft.com. You're going to go to some internal repository or some intranet website or some network share. And it will not necessarily be obvious to the endpoint system where that file came from originally and what it was originally. So they behave differently, they use different kind of resources, and they have different metadata and different attributes available to them to take that decision. So sometimes there's just not enough information about the file or the traffic you're looking at to take a very educated decision, and it's going to hinge on very little. One of the main reasons is obfuscation. So say you are the security staff for a premise, and you're, for example, the security staff at a bank, and this person comes and wants to get into the bank. There's no reason to think this is a terrorist or a bad guy, but you can't know for sure. You don't know who he is. He's wearing a ski mask and balaclava, so you cannot be sure that it's safe to let him in. Probably you will revert to an absolute policy, like, I'm not going to let him in. But if you reject files and software and traffic that are legitimate, that are needed, you have a loss of business. So it depends on context. If you are securing a pub in the Alps, you might actually let him in. The context information is really important, but most likely, even if you know that this person is probably harmless, because this is Andrea Lelli from Microsoft, and I'm the one in white, he's mostly harmless. You probably would let him in the pub, you would still not let him in the bank dressed like that. So when you do that for software and you use packers, you can use it to protect your intellectual property. About 5% of legitimate software use it. And you can use it to compress the binaries, to take less space. However, when you look on the binary editor, on a file that has been packed with a packer, the one on the bottom has been packed and the one on the top hasn't. You can see on the top, you can see some of the strings inside the file. So if the software is calling a web API, you will see it in the string section. If you're looking at the packed file, you cannot see what it's doing. The only way to know what it's doing would be either you knew the file before, but if you didn't know the file before, would be to decrypt it, or to emulate it, or to execute it. That's the only way you're going to know. So all the outer layers of the stack are not going to be able to make an educated decision about what the file is for. They'll have to base their decision only on the context. It's the same for JavaScript. You can have packers for JavaScript. In my experience, packers for JavaScript are kind of useless for legitimate software. They're mostly only used for malware, because you can use minifiers for legitimate JavaScript, and they do pretty much the same, and packers actually introduce bugs. So most people would not use JavaScript Packer for legitimate software. So if you're thinking of using it, I would recommend against it. What you can do to add a little bit of information so that the security software is going to make the right decision is embed into your software information about its source and its context. For example, if you decide to sign all your binaries and authenticate all your traffic with HTTPS, it's going to be clear to the endpoint security stack where it comes from. That doesn't mean it's necessarily clean. Like, we can detect some files that are signed, but if you sign your binaries, that means there's a legitimate entity that exists legally that's willing to put their hand up and say, I did this. I'm in charge of what it does, and I'm taking ownership and responsibility for what it does, and it hasn't been tampered with in transfer. So over time, as you're producing more and more software, you're going to build a bit of trust for your legal entity, maybe your company, or whoever is producing the software. And over time, we will come to trust this signature a little bit more, which will nudge the decision over to the green side. It's not a silver bullet. It's not going to never be detected just because it's signed, but at least we have one more piece of information about what the file is for. The other thing is, if you really want to use a Packer, about 5% of clean software use Packer, but 90% of malware samples we see use Packers. And it's therefore in itself kind of suspicious. Malware tends to use bespoke, custom-made Packers. So if you do want to use one, definitely use one of the main commercial ones. Look it up and make sure it's a popular, well-known one. If you use a bespoke Packer, it's going to look very suspicious to any security software. Some of those Packers also have a polymorphic starter option. That came to light a few years ago when one of our competitors was detecting anything signed, anything packed with Molebox. And a person who was writing software packed with Molebox complained about it to Molebox. So they provided to him a polymorphic starter option so that would evade the detection on Molebox. It wouldn't be able to recognize that it's packed with Molebox. It would just see that it's packed. As soon as they started using this polymorphic starter, the entire security industry started to detect this software, regardless of what it does. Because once you don't know what Packer it is, and it's a bespoke Packer, and you cannot decrypt it, it's just too suspicious. It looks exactly like malware does. So definitely try not to use the polymorphic starter. But my recommendation is sign all your binaries and try to avoid using Packers or use the main ones. I'm going to put my recommendations to the right and then fill up this list of to-do list. And when it is full, we can go for lunch. Okay, show of hands. So you're in charge of the security, you're the security software on a mobile phone. And you have an application that can track the phone, lock the phone, prevent a reset, and demand a passcode in order to let you use the phone again. Do you block it? Raise your hand if you block it. A couple of blocks. Okay, well done-ish. On the left, it's Norton Mobile Security. It does that to prevent theft. On the right, it's a ransomware. It pretends to be a security software, and it pretends to find some threats on your phone when there aren't any. And it demands payment to remove them. If you refuse, it just asks again and again. So you cannot use your phone until you pay them $100 and get a code to unlock it. The point I'm trying to make is behavioral detections are great because you can detect any malware that you haven't seen before. But they're not the end-all. What you want to know is why the behavior occurs and whether the user is aware of what's going on. And that's really difficult for the endpoint software to figure out. it's easy enough to figure out what the software does, but it's hard enough to know whether the user knows about it. So here's another example of that. You have a Microsoft Windows endpoint computer, and you have an app on it that is constantly running. It's monitoring file, and it's sending them to a third-party location, copying them to a third-party location whenever they change. It can execute command, it can list running processes, it can take screenshots. Raise your hands if you block it. 3%. Well done. This is malware. It's an excerpt from our write-up for Trojan NubPub. There's nothing particularly interesting about Trojan NubPub. It's just the first one that I came across when I was looking for Trojan write-up. So again, the point is, it's okay to back up files to a third-party cloud, if that's what the user wants. But technically, a spyware that steals your files and a backup software do the same thing. Just one of them hides. So hiding and stealth can be one indication of whether the behavior is malicious or not. So I would recommend try not to be too stealthy. Definitely have a visible presence on the endpoint. Imagine that you have a moving van that pulls up in your neighbor's driveway, and they're taking away the furniture. Do you call the police, or do you trust that they're movers? It's the same thing with files and backup, right? But that happens all the time. It happened in Le Havre, it happened in Texas, it happened in Mumbai, it happened in Arizona, and it's the same for software. So sometimes spyware will masquerade as backup software, or something that redirects your traffic to a third party for spying can masquerade as a proxy and look just like a proxy in terms of behavior. So if you're writing backup software or proxies or anything that can be a little bit ambiguous, definitely sign your software, sign all your binaries. I've said it before, I'm going to say it a lot. So if you sign the binaries, at least we'll know where it comes from. So if something is monitoring all your files and sending them to a third party and is signed by Google, it's probably Google Drive. Have a clear, visible EULA and user license agreement. Don't go thinking that people don't read it. We read it. We read it all the time. So if you clearly state what the point of the software is and what the expected behavior is, then we'll be able to know if it matches what it actually does. And have a visible presence on the endpoint. Have a GUI, graphical user interface. Have a presence in the system tray. Don't just start monitoring or start backing up and then disappear, because that's what malware does. One more thing you can do, if you want, is proactively whitelist your software. A lot of security vendors have dedicated platforms for that, so you can sign up to their programs. There's also a generic one from IEEE, which is kindly hosted by our friends at Avira. You can search for IEEE-CMX. So you sign up with them and you provide a key, an authentication key, and then you provide hashes from your binaries. You don't have to provide the actual software. Once it's there, any software vendor who is willing to implement this whitelist can consume it. So you would have to do it only once for everybody. One more thing that is kind of confusing to security software is you need to try and keep good company. So if you want to outsource the distribution of your software, sometimes what you can do is use an affiliate program. And they will take care of distributing and advertising it. If you choose one that is not very reputable, what they can do, since they're paid by install, to maximize their revenue, they tend to bundle software together. And sometimes, if they're not very honest, they hide the bundled software installers. So if they use your software and they try to advertise for your software and try to get people to install your software, and they bundle other software with it, technically that turns your software into a Trojan. If they, on the other hand, try to deploy a game or something that is popular, and they bundle your software with it and silence the installer, then that turns your software into a potentially unwanted application. Because people will install that game, and your software will come along with it, and they won't know where it comes from. And whenever they uninstall your software, even though it doesn't cause any harm to the computer, if they update the game, the software will come again. So to them, it looks like it's persistent. It didn't come with their consent, they don't know where it comes from, and it persists through removal. So they call us and complain about it. If that happens, we have to issue a potentially unwanted application detection. There's no way around it. That's not actually a false positive. Here's an example of a bundle. If you want to install this software, by default, the express install tick box is checked, and anything below that is hidden. So only if you click on custom install, that becomes visible, and you can see that the other bundle is ticked by default. For those two reasons, it's chosen by default and it's hidden by default. That's enough to qualify both those softwares for a detection as a potentially unwanted application. So you need to be careful, because we also rely on machine learning algorithms, and they will know which files are associated with your software. So if they see your software always come along with a bunch of unwanted applications, the reputation and the decisions will kind of bleed into the decision we take for your software. Here's another reason to detect something as PO. Oh, sorry. Yeah. POAs are kind of a problem that's often in the news. Another reason to detect it is if you ask for consent for a bundle and the person says no, and then you ask again and again, that also qualifies as a POA. There's about 150 criteria that everybody has agreed on onto why something should be qualified as POA or not. And you can consult them online to apesteam.com if you're curious, and you can abide by those best practices and avoid those POA detections. One more thing that has happened last year. We had a software that was clean and not harmful, and it was being installed by decomposing itself in the temp folder of the browser. So you would go to a website, click on install, and it would come down to the temp folder of the browser, self-extract there, and then deploy from there on the endpoint. There's nothing particularly wrong with that. It works, but it's never, ever used by clean software. Only malware does those drive-by downloads. So in 13 years in Symantec, I've never seen a clean software actually do that. So it hit all of the heuristic rules about the behavior. So when you are deploying and you're writing an installer, it's good sometimes to be able to think outside the box, but maybe channel this into the functionality of the software rather than the deployment method. If you stick to the known practices that work, it will be easier to deploy. So here's what you can do in case of affiliates and to keep good company. If you publish your software yourself on a site like download.com or Softpedia, and you have a freely available version, like a trial version, we will be more likely to be able to tell it apart when we see it bundled with other software. So the software will be already known to us. Some people will have downloaded it on its own. It won't be as strongly associated with the other software in the bundles, which, by the way, can be grayware. So it's not guaranteed, again, but if we see the software on its own, we'll be more likely to be able to clean up the infection and leave your software alone. You can get certified. There's a certification organism called Apesteem. They have a list and a checklist of behaviors that they check for. And if you don't do any of those behaviors, for example, you have a clean uninstaller, you exit cleanly while the installer is running, you do not alter the functioning of the system. For example, you don't change the startup page for the browser. In this case, you can get certified by them. If you don't want to pay for a certification, what you can do is just get the list from their website and abide by those best practices anyway. And this way you're sure you're not going to be qualified as PUA. One last reason that I've seen happen a lot for detections of, I wouldn't say clean, but software that didn't intend to be malicious. It's bugs and vulnerabilities. This is one of my favorite internal tickets. It's from a dispute from a well-known hardware vendor where we were detecting the uninstaller for one of their drivers. And the reason was that the file, when it is passed a process name as a parameter, it kills that process in order to be able to uninstall. But if you pass no process name, it kills everything on the system, including the antivirus and the entire thing. So obviously, this is a bit too much of a vulnerability to have running on an endpoint. Any attacker who has a local access to the machine would be able to kill the antivirus and kill the whole machine. So this triggered, obviously, a detection. This one is an interesting one. You might have heard of it. It's actually a public CVE, so I'm able to actually name them. This is from HP. They issued a version of their audio driver last year, this year actually, June, that was compiled in debug mode. And in debug mode, for some reason, they were logging keystrokes that were happening on the computer. So anything that you would type on the keyboard would go to a clear text log file on the endpoint. They weren't actually trying to steal passwords or credit card numbers. They weren't sending them anywhere. They weren't trying to read that, but anyone else could just use that file to do that. This was resolved really quickly by HP, but the entire security software industry detects this version of their driver, even though it's not intended to be malicious. So before I was saying the behavior is important, but the intention is important as well. Well, the reverse is true, obviously, also. Here's a joke I like by Bill Zempf. A QA engineer walks into a bar, orders a beer, orders 0 beers, orders 999,999,999 beers, orders a lizard, orders -1 beers. I like this joke because I started in QA. Do you know why QA engineers do that? They try to trigger unexpected behavior based on incorrect, invalid, or unexpected input. And the reason is unexpected behavior sometimes can be exploited. So conversely, when we see a file that is corrupt or invalid or looks like it might have been tampered with in order to do that, it has to look very suspicious and it has to trigger an alert from the security software. So whenever we see malformed documents, malformed network packets, corrupt files, it's mostly going to trigger a detection. And obviously, there's legitimate reasons why that might happen. Maybe during the build, one of your files didn't sync properly from the repository, or in transfer before you signed it, something got corrupted. Or even after that, when your customers try to download your software, the download crashed and then it became detected, and then they think that your software is being detected by the antivirus. That's not necessarily the case. But as soon as you have anything that is slightly malformed or that is corrupt, it's going to trigger detection. So maybe be mindful of that. So what you can do to avoid those problems, obviously write secure code. I kind of put it in as a joke because we all try to write secure code. It's worth saying, if you're writing, especially if you're a web developer, it's worth using one of those frameworks that let you scan your application and tell you if you're using any vulnerable functions, because that also looks very suspicious to a security stack when you're using known vulnerable functions. Reactive feedback, like HP did, it was really quick turnaround in this case. Just reach out when you see that something is wrong, that something is detected. You will find out what you need to do. We will respond. And then before I finish, I wanted to point out one thing. If you do see something wrong and something's being detected, for example, you can upload your software to VirusTotal and you see that somebody is detecting it. It might not necessarily affect you or your customers. It might be a vendor that no one in this region uses. Maybe it's a vendor in China that's detecting it. You should definitely dispute it, definitely talk to them, and definitely call it out, because they spread. The entire security industry works together, and they collaborate, and they share all their malware samples, because they compete on proactive detections. But once they find known malware, they want to make sure everybody else detects it as well, so that it gets eradicated. And they do share all their samples that are not covered by non-disclosure agreement. So when a couple of vendors, by accident, by aggressive heuristics or any reason, detect your software, it can spread like wildfire. This is bluejeans.exe. It was a video conferencing software. It happened in June. It became detected by 27 out of 67 vendors, security vendors in total. And it's just a video conferencing software like Skype or WebEx. And it's used quite widely in enterprise space. So even though it's quite popular and it's definitely clean, it became detected by so many people. Because of a bit of a vulnerability in it, and mostly because they did not sign the binaries they were importing. So that looked suspicious to a handful, and then that sample spread. This is also a really good example because we didn't hit on it. So do reach out when you see something wrong. Don't let it just spread. And sign definitely all your binaries. What you can do is upload your software to VirusTotal and see what all the people detected, or upload it to HeartProtect. Use HeartProtect. Actually, you can't upload it to, but you can use HeartProtect to know which all vendors detected. VirusTotal even has an API that you can subscribe to. So you upload it once, and then you subscribe, and they will rescan it regularly and tell you if anyone starts detecting the software after a while. So this is all the lists, so we're soon free to go to lunch. Let me go through it once again. The one thing I would like you to remember from this is definitely sign your binaries and authenticate and use HTTPS. Always sign all the binaries. This is the best way to make sure that we will not hit on clean software by mistake. Try to avoid packers. If you must use packers, definitely use non-polymorphic packers. Have a clear presence on the endpoint. Have a clear EULA, have a clear GUI, have visibility. Make sure that we know that the user knows what you're doing. You can proactively whitelist if you want, through vendor programs or through IEEE CMX. If you have a version or a trial version that's available publicly, that's easier as well. And you can check best practices on appisteam.com and try not to have an installer that breaches any of those. It's actually quite easy to follow. Write secure code as much as you can, and definitely reach out to us and react to FPs and feedback. Thank you. Do you have any questions?